general solution, that is trigonometry. Again, a very simple section of mathematics, but now becomes challenging for the mere fact that it has got three conditions that must be remembered. Once you don't learn those conditions by heart, your problems have started. Now, in the general solution, you must remember that if number one, let's say number one there, if sine theta is equals to A, where A is between -1 and 1, I want to explain this. That is sine of an angle which is equals to A. A is the ratio. If the ratio is between -1 and 1, the condition says, then what is happening? The value of an angle is arc sine of the ratio plus k multiplied by 360 degrees, where k is an element of integers. Or theta is equals to arc sine of A plus k times 360 degrees, where k is an element of integers. Now, this is the condition for sine theta. Let's enclose it beautifully there. Condition for sine theta, which must be remembered. Then we have the second one. If we are not dealing with sine theta and we are dealing with cos theta equals to a ratio, where the ratio is bounded between -1 and 1 again, then theta is equals to plus or minus arc cos of A plus k multiplied by 360 degrees, where k is an element of integers. Now, this one is condition number 2. And condition number 2 deals with cos. Condition number 3, what if we are not dealing with cos, we are not dealing with sine, but now we are dealing with tangent theta, which is equals to a ratio. Remember the shape of tangent graph. A is an element of real numbers. Now in this case, because the tangent graph is not bounded, it does not have minimum and maximum unless if you restrict it. Now, in this case, then theta is equals to arc tan A plus k times 180 degrees, which is the period for tan, where k is an element of real numbers. Now, this is condition number 3. Folks, please, when you deal with trigonometry and you are preparing for your exam, make it a point that when you prepare for the general solution, you actually learn these by heart. They are very important. Now, let's see how we use these. The example says, determine the general solution of the following equation. The equation is sine squared x plus cos 2x minus cos x. Remember now, in grade 11, you did square identities. In grade 12, you did double angle identities. Now, can you see that this can be substituted by its identity, and that can be substituted by its identity? But what about that one? There's absolutely nothing. Meaning that we are going to keep this one as it is and try and express these ones in terms of cos x. Now, I'm going to do that. Sine squared x is the same as 1 minus cos squared x, that we know, plus cos 2x. It is now that challenging one which has got three things. It can be cos squared x minus sine squared x. It can be 2 cos squared x minus 1. It can be 1 minus 2 sine squared x. Now, in this case, because I want cos x, I'm going to write cos 2x in terms of cos x only. That is going to be 2 cos squared x minus 1. Then we bring that one down as it is because we can do nothing about it. Now, we end up with this. Now from here, I'm going to look for what I can do mathematically speaking. Can you see that I've got like terms? Now, I must either add or subtract them depending on their signs. 1 minus 1 is a 0. I can cancel that one out. Now, minus cos squared x plus 2 cos squared x is cos squared x. Then I have that one which I can do absolutely nothing about. Now, I have this binomial, which is a quadratic equation, but now not the difference of two squares. That means I must remove the highest common factor. And the highest common factor is cos x. Then I'm left with cos x minus a 1, which is equals to 0. Now from here, cos x is equals to 0 or cos x is equals to 1. I hope that you follow this. Remember, mathematics says if you multiply a by b and you get 0, either a or b is equals to 0. In this case, my 0 is 0. In this case, my 0 is 1. Now, look at what we have done here. We have simplified this equation to such an extent that now we have a trigonometric function equated to a ratio. Trigonometric function equated to a ratio. I normally say that we have written it in a standard form. Standard form, let's come and check this side. I'm not dealing with sine, I'm not dealing with tan, but I'm dealing with cos. Now, I have got two equations. Number one is cos x, which is equals to 0. Now, remember, 0 is between minus 1 and 1. And we said if cos theta is equals to a, and a is between minus 1 and 1, then theta is equals to plus or minus r cos of a plus k times 360 degrees. That means that I can write this as x is equals to arc cos of 0 plus k times 360 degrees, where k is an element of integers, don't forget that it is positive or negative. Now, you take your calculator there, you push arc cos of 0. Arc cos of 0 would be a 90 degrees plus k times 360 degrees. Please now remember it is positive or negative. I'm going to write first the positive, then x is equals to minus 90 degrees plus k multiplied by 360 degrees. It is now this one. Remember, most mathematicians don't like this plus or minus notation. That is why I'm separating them. I'm one of those mathematicians. Or I'm now going to equation 2. Equation 2 says cos x is equals to 1. Now, I'm coming this side. Cos x is equals to 1. I'm there again. It must be greater or equals to minus 1, less or equals to 1. And it is equals to 1 there. Therefore, that means x is equals to plus or minus arc cos of a 1 plus k times 360 degrees, where k is an element of integers. Now, I take my calculator, I push arc cos of 1, and it gives me arc cos of 1 would give you 0 degrees plus k times 360 degrees, where k is an element of integers. And in this case, 0 cannot be positive or negative. It would just be 0 degrees plus k times 360 degrees, of course, which I can write as k multiplied by 360 degrees. What did we do here, folks? We have written the general solutions of this particular equation. Remember, I want to stress this again. The conditions are so important. Learn them by heart. Number 2, don't forget your identities. Number 3, make it a point that you do your correct mathematics up to that point so that you get the standard form, which would be either this or that or that. I thank you very much. All the best.